Hi dear students, good evening all of you. Good evening Ma. Good evening Sharanya. I hope I am audible. Yes. Okay. Welcome to Geeta's classes. So today we are going to see Unit 5, Class 2. I forgot to upload that classes. Okay. So Unit 5, Class 2. Okay. First class we have seen some problems. We have seen some definitions in stochastic process. So we have seen what is a stochastic process. It is random process. It is equivalent to the word random process. Okay. So if you have the random variable with time t, if you consider with time t, then it is a stochastic process or random process. Okay. Hi Ma, hi Sam. Hi, good evening. So today we are going to see some more definitions and some problems also, important problems. And two important problems I have explained in the previous classes. I mean, a separate class is there for 2-3 problems. Okay, those problems you can go through again in that YouTube channel. It is available. Okay. So here first let us see the definition accessible. The definitions are important. All the definitions are important because in 5th unit we have 50-50. Chances are there for getting problems and theory also. Okay. So 50-50 chances will be there. So please concentrate on the theory topics also. Okay. So accessible means, suppose if you have two states, if you can reach the other state, we say that J is accessible from state I. We write like this, that is from I you can go to J. The representation is like this, I to J. Then J is, we say that J is accessible from state I, that is from I you can go to J. J is accessible from I. Okay, that is the meaning. From I, if you have a path to go to J, then path in the sense, even if it is mentioned in terms of matrix, you have to write the graph. When we do the problem, you will understand clearly. Okay. If Pij, the probability of going to J from I is greater than 0. What do you mean by this Pij per n? If you write like this, the probability of going from I to J in n steps. In n steps. Okay. That is the meaning of Pij the whole per n. Okay. So Pij the whole per n means the probability of going from I to J in n steps. Right. And always the probability should be greater than 0. So for some n, if it is like this, then we say that J is accessible from I. We assume every state is accessible from itself. So that is Pi of 0 is equal to always 1. Because 1, when will you say the probability is 1? It is certain. It is sure that it happens. Okay. So every state you can reach from the same state. If we assume like that. Therefore, Pii of in 0 steps. Okay, we are not going to anywhere. Therefore, it is Pii of that is from I you can reach I in 0 steps. That is the meaning of Pii per 0 is equal to 1. Okay, then communicate. This is another word definition, communicate. So, two states I and J are said to communicate, written as I like this. That is I is communicable to J, as if they are written as I communicative to J if they are accessible from each other. If they are accessible from each other, that means what? You should be able to go from I to J and J to I also. Okay, you must be able to go from, you should have a path from I to J and J to I. That is I I is communicable to j means you should be able to go from I to j and j to I. This is the meaning. And it is an equivalence relation. That is, you should be able to reach from I to I. Just now we have seen it is possible. Therefore, it is reflexive. This relation, equivalence relation, not equivalent relation. It is equivalence relation. Okay. Equivalence relation. When will you say that the relation is equivalence relation? If it is reflexive, symmetric and transitive. What do you mean by reflexive? This you would have studied in your intermediate, right? So reflexive means every A, that is, for example, if you consider the set. Generally we write the function and relations like this. A is related to A. That is, A should be related to A. That is, A comma A belongs to this relation. For all A in the set belongs to A. Wherever it is defined, then it is reflexive. Then if I is communicate with J and J communicates with I, then it is said to be symmetric. That is, if this is possible, then this should also be possible. If you have a path from I to J and J to I, definitely you can write J to I and I to J also. It is also possible, right? By seeing that itself we can say, if you can go from I to J and J to I, definitely you can go from J to I and I to J also. Okay, that is the meaning. Then if I is communicate to J and J is communicate to K, then I communicates to K. This is the transitive relation. Generally we know A is equal to B and B is equal to C implies A is equal to C. We write, no? It is like that. Okay. Sorry, this as is not there. Okay. So now we'll see some problem whether it is communicative or not. From 1, what about 1? From 1 you can go to 2. So Y is 2 is reachable from 1. Okay, you can write like this. 2 is reachable from 1. What about 3? Yes, 3 is reachable from 1. Right? Then is 4 reachable from 1? No, not possible. Right? What about 5? From 1 can you go to 5? No, not possible. So 5 is not reachable. 4 is not reachable from 1. 5 is not reachable from 1. Okay. This is how you have to write. Okay. Then what about 6? Are you able to reach? Can you reach from 1? Can you reach 6? No. When you go inside 2 and 3, from 3 you cannot come out, so it is not possible. But 2 is reachable from 1, 3 is reachable from 1. 1 is reachable from 6. I'm sorry. From 6 you can go to 1. So 1 is reachable from 6. Right? And what about 1 is reachable from 5? Yes. From 5 you can go. And 1 is reachable from 4 also. Right? These are the meanings. Right? What about 2 and 3? From 2 is reachable from 3 and 3 is reachable from 2 and 2 is reachable from 3. That means 2 and 3 communicate with each other. 2 communicates with 3. That means 2 and 3 are communicable. Okay. Similarly, what about 5 and 6? From 5 you can go to 6 and 6 you can come back to 5. So 5 and 6 are communicable. Okay. 5 communicates with 6. This is the meaning. Now, very, very important question. Recurrent and transient states. Recurrent and transient states. Okay. So for any state I, we define Fii is equal to probability of xn is equal to 1. For some n is greater than or equal to 1 and x0 is I. Okay. If you define like this, that is, what do you mean by probability is 1? It is certain. Right. That is, if you start from one state I and if you are going to some other states and if you are able to come back to I, then we say that it is recurrent. It is recurrent. Okay. Otherwise, it is transient. Very simple. If you start from one state and if you can come back to that state, it is recurrent. Otherwise, it is transient. Okay. So, if it is recurrent, what about the probability? because it is continuous, you consider FII, PII also you can say nothing wrong. Then it is it is certain, so the probability will be 1, and if it is transient the probability will be less than 1. Definitely it is not 1, you cannot come back, right? So it is less than 1. So in general, it is state is said to be recurrent if any time we leave that state, we will return to that state with probability 1. Okay. If the probability is returning is less than 1, then the state is called transient. Okay. Now let us see all the states. For this, let us find out whether it is transient or recurrent states. Can you tell me which states are recurrent states now? From this diagram, can you tell me which states are recurrent now? You tell me which states are recurrent and transient. What about 1, 2, 3, 4, 5, 6. Tell me whether they are transient or recurrent. From 1, you are going out of 1. Can you come back to 1? What is the meaning of recurrent and transient? Recurrent means you should be able to come back. Recurrent means you should be able to come back. Okay. Transient means you cannot come back. That's the meaning of, that is the difference between transient and recurrent. Recurrent state means you can come back. Yeah. 2 and 3 are 5 and 6. Very good, Sagar, actually. Very good. Are recurrent. Yes, ma. Very good. Excellent. 2 is recurrent. See, from 2 you can go to 3 and 3 to 2. You can come back to 2. It is certain. Therefore, they are recurrent. What about 1? From 1 you can go to 2. From 2 you can go to 3. From 3 you cannot. Okay. From 3 you may have a doubt actually. 1 to 2. From 2 to 3. Then 3 to 2. Again, can you come back to 1? No, it is not possible. Yes, it is not possible. Okay. Yeah, 5 and 6 are recurrent. Yes, ma. Correct. Pratyusha, right. Yes, correct, ma. Very good. 2, 3, 5, 6. Yes. Wait. Correct, Sagar and SM. Your guess is right, but there is a small twist. Sagar and SM. Wait. What about 2 and 3? You can say. What about 1? Okay, let us see one by one. 1. You can go to 2 to 3. From 3 to 1, you cannot come back. Therefore, it is obvious that it is transient, right? Okay. All the states one by one we'll find out. Okay. Yes. What about 3 now? Self loop can be recurrent, ma. It can be recurrent. The thing is, you should be able to come back for certain. You must be sure that you have to come back. If you are sure that you can come back, then only it is recurrent. From 2 you can go to 3 only. From 3 you have to come back to 2 only. No other go. Okay. Therefore 2 is recurrent. 3 is also recurrent. What about 4? From 4 you can go to 5. And 5 to 6 you cannot come back to 4. You cannot come back to 4. Therefore it is transient state. Right? Okay. Now what about 5? Listen. From 5 I can go to 6 and I can come back to 5. One possibility. From 5 I can go to 6. Again self loop. Again I can come back to 5. This is another possibility. From 5, from 6, if I don't take this route or this route, I can go back. From 6 there is another way also. I can go to 1 also, no ma. From 6 you can go to 1 also, right? In this case, when it comes out of 6, can you come back to 5? 5 will go to 6 and 1. Yes ma, that's what. 5 will go to 6 and 1. If it comes to 1, from 1 can you come back to 5? Is there any possibility? Is there any possibility to come back if it goes? See, from 5, if you are going here and coming back, fine. If you are taking another route also, fine. Second time, okay. If I go to this route and here, is it possible to come back to 5? Anyone? Anyone? Is it possible to come back to 5? If I take this route 5, then if I come back, if it comes out of 6, is it possible to come back to 5? No. In that case, see, always remember recurrent relation, recurrent state means it is for sure. If you are sure that you have to come back like this, from 2 you can go to 3. From 3 there is no other go. You have to come back to 2. Okay. Therefore 2 and 3 are recurrents. Similarly, from 3 if you go to 2, definitely from 2 there is no other outgoing, right? So you have to come back to 3 only. Therefore 2 is recurrent, 3 is recurrent, 5 is not. 5 is not. Okay. Understood? So 5 is a transient state. It is not a recurrent state. It is a transient state. 6 is also the same thing. From 6, if I go to 5, you have to come back to 5. But from 6, if I take this route, it is not possible to come back. Understood? Therefore, yes, ma, transient. It is transient. It is transient. Understood? If you are very sure that you have to come back to that state, then only it is recurrent. Otherwise, it is transient. Understood? That is why I have taken this example. From 5, you can either come back to 5, or you may go to, if from 6, if it comes out to 1, then you cannot come back. Then in that case, it is transient. Understood? Yes. Any doubts? Transient state and recurrent state. Usually you will get questions like this, graph will be given or matrix will be given. I'll tell you how to write that. Yesterday I think we have seen from matrix to graphical representation also. Okay. So like this, so if you are given a matrix or the graph, you will be asked to find out the states, whether it is transient or recurrent and all. This is an important question. You can expect one question from this topic, transient or recurrent. Okay. Any doubts? Shall we go to the next one? Another important topic, period. The period of a state I is the GCD. Is what GCD means? Greatest common divisor of n, such that PII of n, that is from I you have to start and come back to I in n step. PII of n means what? Starting from I and coming back to I in n steps. This is the meaning. PII power n means you have to start from I and come back to I in n steps, and is denoted by d of I. The period of a state is how many ever possible ways you have to, how many steps are available. You find out all the ways to come back to I and find out if there is only one way, then one only. Okay, it is one only, right? And if there is no other way also, if you are not able to come back also, it is one only. Degree is one only. Period is one only. Okay. And if the period is 1, it is called aperiodic. If it is greater than 1, it is called periodic. And greater than 1 means whatever number you are getting, that is called the period. Okay. Otherwise, the period is 1, then it is called aperiodic. Okay. If I and j are communicating with each other, then definitely the period of I will be equal to the period of j. We'll see one example. Yes, ma, R18 regulation only. R18 regulation only. Yes, ma. All the topics are available in the channel, ma. You can go through. Even unit wise it is available. Unit 1, 2, 3, 4, 5. Okay. This is 5th unit. This is a revision only. We are doing revision. Okay. Even revision topics are available separately. Let us study Cosm, COSM. You will have like this. Let's study a series like this. Let's study COSM. Yes. Okay. You can go through that. Important topics means very repeated questions and all. We are just revising that topics. Okay. You can go through them. So now let us find out the period of all the states. Now period means what? It is the, you have to take, if you have only one root, then you have to take the number of steps, right? If it is more than one, then you have to consider the greatest common divisor. Okay. What about 1 now? You consider 1. Consider 1. What about the degree of 1? Period of 1. From 1, you have to go back to, if you are able to come back to 1, then you can find out this, right? Otherwise, always it is 1 only. You have to go to 2, from 2 to 3, you cannot come back to 1. So the period is always 1 only. Okay, if it is not possible to come back also, you consider the period is 1. Okay, now what about D of 2? D of 2, from 2 you can go to 3 and 3 to 2. There is only one possible way. There is no other possible way. So the period of 2 is 2. Period of 2 is denoted by D of 2. It is 2. Okay. What about the period of 3 ma? From 3 you have to go to 2 and from 2 you have to come back to 3 only. So how many steps? 2 steps. Okay, that is called the period. If there is only one way, you write the number of steps. This is steps. In 2 steps, you are coming back to 2. In 2 steps, you are coming back to the same state. Okay, these are all states. 1, 2, 3, 4, 5, 6 are states. Okay, so in 2 steps, we are coming back. Therefore, the degree is, period is 2. What about period of 4? What about period of 4? Period of 4, if when you go out of 4, is there any possibility to come back to 4? No, it is not possible. Therefore, it is 1. Therefore, it is 1. Okay. What about D of 5? D of 5. See, I can go back to 6 and I can go to 6 and come back. Okay. So, there are 2 steps. In 2 steps, I can come back. One possibility. 1, 2, 3. This is another possibility, right? Either I can go like this from 5 to 6 and 6 to 5. That is 2 steps, one possibility. From 5 I can go to 6. Then from 6 again you can take the loop, then come back to 5. So there are 3 possibilities also. 3 steps also is possible, right? In this case you have to take GCD. If there are more ways, then you have to take the greatest common divisor of the number of possible ways, that is the steps, n steps. Okay, 2 steps you can come back or 3 steps you can come back. So GCD of 2, 3 is 1. Greatest common divisor of 2, 3, 1. Understood? So similarly, what about 6? From 6 you can go to 1, you cannot come back. So don't consider, maybe 1. So 6 to 5, then 5 to 6. There is one possibility, that is in 2 steps. Similarly, you can from 6 I can go to 5, then 5 to 6, then I can take this route also. Okay, so 3. So 3 steps also is possible. So GCD of 2, 3, it is again 1. Understood? So like this you can find out the period of all these states. Now I have 1, 4, 5, 6. They are called what? How many? What is the period? They are called aperiodic. If the period is 1, then it is called aperiodic. So here 2 and 3 are having periods 2. They have periods 2. Understood? Another important question, find the period of all the states. You can expect like that also. Okay. Any doubts in this? Any doubts? You have to find out the periods. Period is, if you have 2, 3 ways, then for 6, the period is 1. Yes, ma. For 6, the period is 1. Yeah, it is aperiodic. Because you have, see, from 6, you can go to 5 and 5 to 6. That is one possibility. 2, then 5, 6, 5, 6, then again 6. You can take this also. So in that case you will get 3. Yes ma'am, it's 1. Yes, very good Sharanya. Yeah, correct. For 6 the period is 1. Very good. So 1, 4, 5, 6 they are called, if it is 1 it is called a periodic, otherwise the period. So 2 and 3 are having periods 2. See, and another point we have seen, if I and j are communicate with each other, then the degrees, periods are same. Periods are d of I is equal to d of j, right? Here 2 and 3 they communicate with each other. Okay, so period of 2 is 2 and period of 3 is also 2. This is what is given in this. If I communicate with j, I and j are communicate with each other, then the period of I and period of j are equal. Okay. Next, another very important questions. All these topics you can expect one minimum 5 marks or 7 marks questions you can expect. And I think the COVID paper only, that day somebody mentioned, no, the COVID paper only, but the time period is increased mark. Previously you used to write 2 hours, I think. Now you have to write 3 hours, and I'll confirm that once again, okay, in the next class or so. I'll confirm that, but what I heard is I got some information that it is going to be COVID paper with 3 hours. Same pattern only. Okay, there is no A, B, C, D and all. I mean 2 marks, 3 marks questions will not be there. Okay, 8, 7, 8, 7, 8, 7, 8, 7 like that. So next, another important topic is irreducible and ergodic. One definite question you can expect, some TPM, that is the transition probability matrix will be given, and you will be asked to find out whether it is irreducible or not, whether it is Markov chain or not, ergodic or not. These kind of questions you can expect. So a Markov chain is said to be irreducible if all states communicate with each other. From any state you should be able to reach all the other states, then only it is said to be communicate. Okay, if you consider any states, you should be able to reach all the other states, then it is said to be irreducible, otherwise it is reducible. Okay, and ergodic means consists of one equivalence classes, and all elements of this class are recurrent and all the states are aperiodic. Just now we have seen all these definitions. Okay, A and B will not be, part A, part B will not be there, only one part, and you will have I'll explain all these things in a separate class. Okay, part A and part B will not be there. Part A usually, part A you will have 2 marks and 3 marks. No, they will not be there. Only one part, no part A, part B and all. Okay, only one part, and usually you will have first question will be AB with 1 8 marks, 1 7 marks. Sometimes in 2 AB, either this one or 8 marks and 7 marks, or 7 and 8 also, sometimes 7 and 8 also, depending on the question they'll give like that. Generally 8 and 7, yeah, in question, in university question I'm telling, not for midterm, this is for university question I'm telling. Okay, yeah, like 1A 1B, yeah, yes, 1A 1B will be there. Yes ma'am, 1A 1, I'll explain, don't worry. Exact pattern I'll confirm, and we'll discuss some questions like that with you with the previous year question paper also. I'll explain. Okay, yes. So these definitions we have seen. Aperiodic means what? The period should be 1. Sometimes 5 plus 5 plus 5 is also available. Yes ma, yes ma'am, you are right. Yes, sometimes even in this A, B, C with 5 marks also, 5 marks each, that also is possible. Yes. Depends on the question, they will give the marks. Sometimes that's what 4-5 steps, mathematical calculations, 4-5 steps will be given, 7 marks, 8 marks questions also sometimes. Okay, that's what, always don't see the marks, you just study the topics, right? Yes. Now I'll give you some examples. See, if I have this 1, 2, the state 2, 3, 4, 5, 6, Tell me which states are recurrent. Which states are recurrent, which states are transient from this? Tell me which states are recurrent, which states are transient. Is it ergodic or not? Is it ergodic or not? If ergodic also, you should tell that everything is possible. If it is not ergodic, at least one reason you have to give. That's all. One reason if you give, enough. Tell me in this is which states are recurrent, which states are transient. Which states are recurrent, which states are transient. Which states are recurrent, which states are transient from here? Yes, tell me please. Have you seen which states are recurrent, which states are, all are recurrent, very good, very good. Yes, ma'am, all are recurrent is right, very good, excellent. Yes, ma'am, all are recurrent, right? No transient state, because from 1, if you start from 1, from 2, from 1 I can go to 2, 3, 4, 5, 6 and I can come back to 1. If you consider 2, from 2, 3, 4, 5, 6, okay. All are recurrent. Yes, ma. Yes, all are recurrent. Correct. Correct. Very good. What about ergodic? We can access them. Yes. Not access them. If you start from one state, you should be able to come back to the same state. Okay. You should be able to come back with probability 1. That means you are certain that you have to come back. From 2, you have to come back to 2. No other go. Okay, actually from 6 you cannot go to some other state 7. If you have the like this, then there is a question of transient state. Okay, here no other possibility. From 2 if you start, you have to come back to 2 only. If you start from 3, you have to come back to 3. Like this, all these states are recurrent. Yes, ma, very good. All the states are recurrent. Very good. All of you understood. All states are recurrent. Okay. All states are recurrent. Is it ergodic? What about the states? If all the states are ergodic, then the Markov chain is ergodic, we see. If you want to find out whether a Markov chain is yes, all are recurrent is right, ma. Correct, Sharanya. Very good, very good. All of you understood. Very good, excellent, excellent. All the states are recurrent. Ergodic, you did not understand. Okay, ma. See. All these elements are equivalence classes, means you should be able to go back from you have to consider these 3, that is from I, always I communicate with I. Okay, if I and J are communicable, then definitely J and I are communicable. Yes, this is also possible. I and J are communicate with each other, and J and K are communicate with each other. I and K they also communicate with each other. That's what I'm explaining. Yes, Sam. Yes, ma. So I and K are so this is also possible. Always recurrence. Suppose if you see the communicate relation, definitely it is equivalence relation. Okay. So here you need not worry about that, right? Definitely it is equivalence relation. Okay. So now all elements of this class are recurrent. What about the third topic, third point, all these 3 points? What about, you have to check whether all these states are aperiodic or not. Now you tell me what is the period of 1. Period of the state 1. Period of state 1. That is di. D of 1, sorry. What is d of 1? Wait, Sagar. Wait, ma. Wait. What about period of 1? What is period of 1? Here I have explained. See, period of 1. From 1, if you are not able to come back, the period is 1. Okay. If you can come back in only one way, then in how many steps you are coming, that number you have to write. For the period of 5, what we have taken, either you can come back like this 2 steps or 3 steps. Okay, so if there are more than 2 ways, more than one way, definitely you have to take the GCD. Very simple, don't get confused. Don't get confused. For degree of the period of 2, what did you do? From 2 you should be able to come back. Okay, you should be able to come back. In how many steps you are able to come back? From 2, one step you have to go to 3. The next step you have to come back to 2. There is no other go, right? So 2 steps I have come back to 2. Therefore, the period is 2. This is the only way. Therefore, the it is 1. It is 2. Okay, period of 2 is 2. From 3, if you consider 3, from 3 I can go to 2, then 2 to 3 I can come back, right? In how many steps? Steps I have come back to 3? 2 steps. 1, in one step I have reached 2, the next step I have come back to 3, right? Therefore, it is 2. Therefore, it is 2. Now, in this tell me, if I start from 1, in how many steps I can come back to 1? This is the question. Is it possible for you to come back to 1? Yes, it is possible because it is recurrent, right? Recurrent means you should be able to come back to that state. In how many steps you can come back to 1? In how many steps you can come back to 1? From 1 I can go to 2. From 1 you can go to 2. 1, then 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6. In 6 steps you are coming back to 1. Yes, ma, 6 steps. Yes, very good. Yes, very good. It is not period 1, Sharanya. It is not period 1. Venkatramana, this is 1 step, ma. Sorry, not the states. You are not supposed to count the states, okay? This is 1 step I am reaching from 1 to 2. In how many? No GCD, ma. Only one way, no. There is only one possible way, no SM. Don't get confused. If there is only one way, how many steps you have to come back? See, from 2 to 3, 3 to 2. How many steps we have come back? 2 steps. So it is 2 we have written, right? 2, right? Not 6 comma minus 1. 6 comma 1. No. It is 1 only. Degree of, period of 1 is how many steps you can come back? 6. So 6 is correct. 6 steps, no sir, 6. That's all. If there are 2 ways, then only go for GCD. Here only one way, only one possible way. From 1 you have to go to 2. You have to go from 2 you have to go to 3. From 3 you have to go to 4. From 4 you have to go to 5 and so on. From 6 you have to come back to 1 only. There is no other go. No other method. No other path. Okay, only unique path is available. Okay. Yeah, it is periodic. Yes, ma. Yes. Very good. Sagar, yes. It is periodic. With period 6. 6 is called the period. 6 is called the period. That's all. If it is 1, a periodic. Otherwise, period. With period, how much? 6 is the period. Got it? So, period of state 1 is 1. What about period of state 2? Period of state 2. If you have understood now, you have to write. Sharanya understood? Yes. I hope you understood. Now try again. What about period of state 2? You post the answers, no problem. Even if it is wrong, nothing. You need not worry about that. Okay. What about period of 2? Period of 3? Period of 4? Period of 5? Yes, ma. Total chain is periodic. Yes. With period how much? With period how much? What is the period? Correct, Sagar. All are periodic. Yes, ma. Very good. All are periods. Yes, very good. Super. 6. 6 is correct. 6 is correct. Yes, Sam. Correct, ma. 6 steps. Yes, Sagar. Correct. Excellent. Excellent, all of you. Yes, period of state 2 is 6. Yes, ma. Yes, yes. Yes, correct. Total chain is periodic. That means all the steps are, all the states are periodic. Therefore, it is not ergodic. If it is aperiodic, then only. If all the states are aperiodic, then only it is ergodic. See, for ergodic condition, all the states should be aperiodic, right? Here, all the states are not aperiodic. All the states are having period 6. Therefore, Sharanya understood? Yes, ma. All the states are period 6. Yes, ma. All the states period is 6 only. Therefore, it is not ergodic. It is not ergodic. Got it? It is not ergodic. Yes. I hope all of you understood. Yes, ma. Easy, no? Very easy. You have to understand, that's all. Yes. Yes, ma. Very good. Very good. Yeah. Next. Another important question. This is a repeated question. Repeated question. 2-3 times they ask this question. Okay. So 3 boys A, B and C are throwing a ball to each other. A always throws the ball to B and B always throws the ball to C. But C is as likely to throw the ball to B as to A. Show that the process is Markovian. Find the transition matrix and classify the states. All these all the states ergodic. 1 second, ma. Before that, I want to do one more question. See, here you have told that all are a period, all are having period, right? Period 6. The same problem, listen. 1, 2, 3, 4, 5, sorry. 5, 6. If I include one line here, what will happen? If I include one line here, what will happen? Yeah, take another example. Yes, ma'am. Here, tell me. Here, tell me, is it ergodic or not? Is it ergodic or not? What about the states? All the states, are they recurrent or not? All the states, are they recurrent? From 1, can you come back? Is it possible to come back to? In whatever way you take, you should be able to come back. Then it is recurrent, right? See, from 1 to 2, 2 to 3, 3 to 4, 5, 6, 1. One possible way. 1, 2, 3. From 3, even if you go to 5, definitely you have to come back to 1. Therefore, 1 is recurrent. 1 is recurrent, right? What about 2? Same way. From 2, you can either take this way or this way. So, recurrent states are 1. All the states are recurrent here. Understood? All the states are recurrent. All states are recurrent. All states are recurrent. Yes. Is it ergodic? Is it ergodic or not? Tell me. Venkatramana Reddy, correct ma? 6 is right for the previous problem. Correct. Very good. Yeah, you can come back for all. No problem. Yes ma. That is why all are recurrent. All are recurrent. You can come back. See, if sometimes in the previous question we have seen from 6, if you go out, you cannot come back to 5. Therefore, 5 is not recurrent. Okay. So, here it is possible. Definitely you can come back. So, you have to come back to that only. Therefore, they are recurrent. Yes. What about ergodic? Is it ergodic? Or what? Now, tell me what is the period of 1. Tell me what is the period of 1. What is the period of 1? Anyone? Correlation topic. Correlation is not there for you. Correlation is not there, ma. In our syllabus, we don't have correlation. SM1, very good, very good. How? How? How is it 1? We have how many? 6 and yes ma, very good, very good, very good, very good Sagar. Yeah. D of 3 is GCD of 5 comma 6. GCD is 1. Yes, ma. See, degree of 1 also, no? 5 comma, not 5 comma 6. Yes, is it 5? So 1, this is 1, 2, 3, 4, 5, 6. 1 is 6. Okay. One path is 6. One step is 6. Yes, ma. 1, 2, 3, 4, 6, 1. Yeah. 1, 2, 3, 4, 6. No. 4, 5, 6, 1. No. 1 is 1, 2, 3, 1, 2, 3, 4, 5 also is possible. 1, 2, 3, 4, 5. So 6 comma 5, right? 6 comma 5. So 2 ways means what? You have to go for GCD. Yes, ma. Very good. Excellent. Excellent. Yes. Yes, ma'am. First itself you told 1. Yes, ma. Excellent. Understood? No. Yes. Sagar also. 5 comma 6. Yes, ma. Very good. Excellent. So it is 1. Yes. Correct. Got it? Yes. What about D of 2? What about D of 2? Period of 2. Period of 2. Period of 3. Etc. No problem, no problem. Yeah, understood. I got it. Yes. 2 ways. Yes, ma. Correct. No, your answer is right only. Correct only. Yes. Yes, ma. D of 2. What is period of 2? Anyone? Period of 2. Similarly, find out for all. D of 3. Same. Very good. Excellent. Excellent. Yes, excellent. 1, 1, 1. D of 4 is also 1. D of 5 is also 1. D of 6 is also 1. Now tell me, what can you conclude from this? Therefore, the given chain is. Therefore, the given. For 2 also, yes, same. For all the 6, it is same. For all the 6 states, it is same. For all the 6 states, it is same. 1 only. That means it is ergodic. Very good. Lomith. Yes, very good. Therefore, it is ergodic. Not to be seen. Lomith. How are you? Yes, ma. Yeah, 1. So it is aperiodic. Yes, ma. Yes, it is ergodic. Ergodic. Understood? No? Very good. Sagar is some. Yes. Yes, ma. Very good. Very good. Excellent. Excellent. Got it? No? So any problem is given, you should be able to do. Right? You remember this. What is the definitions? Yeah. Sharanya, D of 2 is 1. Yes, ma. Correct. Got it? No? Similarly, for all the states, you will get 1 only. Sharanya. You will get 1 only. That means what? All the states are aperiodic. So, all the states are recurrent and aperiodic. And we know that this it is equivalence class. You will have at least one equivalence class. That is this relationship. It is a recurrence relation. Okay? Yes. Okay, Lomit. Yes, ma. Okay. Studying now? Yes. Fine. Okay. So this question we'll see. Last question. Okay. 3 boys A, B and C are throwing a ball to each other. A always throws the ball to B and B always throws the ball to C. But C is as likely to throw the ball to B as to A. Show that the process is Markovian. Find the transition matrix and classify the states. All the states are all the states ergodic. So if I give the matrix, definitely you will be able to do all the remaining things. First, let me find out the matrix. I have 3 persons A, B, C. Sorry. I have 3 persons A, B and C. Here again A, B, C. What is given? A, B, C are throwing the ball to each other. A always throws to B only. If the ball is with A, he will always throw to B only. That means A cannot keep himself. Yes, Venkatramana Reddy. Yes, ma. 1 is correct. 1 is correct for all. Yes. Correct, no. And A never throws to C. Therefore, the probability is 0. A is always throwing to B only. Okay. And B always throws the ball to C only. B always throws the ball to C only. Sorry. This is 1. So remaining, B cannot keep himself and B cannot throw to A. B is not at all throwing to A. Okay. So it is 0. Yes. Now what about C? C is, but A is always throwing to B is always throwing to C. But C is as likely to throw the ball to B as to A. So what is the probability of C throwing the ball to A and B? They are same, that is 1 by 2 and 1 by 2. C cannot keep it himself, therefore this is the matrix. Right? Now you have to check whether this process is Markovian or not. Suppose if you consider the state x0, initially suppose assume that the ball is with A. Okay, in the initial state it is with A. From A, what is x1 in the state 1? Okay, wait. Suppose if the ball is, I am starting from A, this is the 0 state, okay, or x0 you can say. From A always he is throwing to B only, right? So this is with probability 1, okay. Now this is state x1. This is the first state, initial state. Initially the ball is with A and A is always throwing to B with probability 1. This is the probability. We are writing the probability here, right? Okay, right? So this is x1. If the ball is with B, then he always throws to C only. B always throws to C only. Therefore, again probability 1. Okay, this is state x2. What about x3? Now, C means there are two possibilities. Either C can throw the ball to A or B with 1 by 2, 1 by 2. So, x2, then x3. Okay, suppose if he is throwing to A, then the probability here is 1 by 2. Okay. Now, if I have, if this is the state, can you say that x3, will you say that now the ball is with A? Because A has started, C has thrown to A. Can you say that, can you say that because it started from A, C has thrown to A? No, not at all possible, right? Because C from C means, suppose if this is x4, x3 or x4, okay. If you consider, or x3 you can say either this one or this one, right? So even this can be x3. If you consider this state, it depends only on C. Not, it is just the preceding state. It is depending only on the preceding state. Because the ball was with C and C can throw to B, he has thrown, that's all. Okay. And it is not because the preceding state, two states before that it was with B. Because of that he has thrown here. Nothing like that. Nothing like that. Okay. So, if it depends only on the preceding state, not on the other states, then you can say that it is Markovian. Now tell me, is this process Markovian or not? Is this, now I have explained this. Now tell me, is this state Markovian or not? Yes? Is this state Markovian? This process, can you say that is it Markovian? If it depends only on the preceding state, not on all the other states, then it is said to be Markovian. Now, because the ball is with A, definitely it has to go to B. Because now the ball is with B. From B, it can go only to C. Yes, ma'am. And connect C to X0 with... No, C to X... See, states, no. States, no. It is state. I have started from here, that's all. You cannot come back now. Now we are not talking about this coming back. Coming back. It is not coming back. Now even if you say A, it is not state. You can go to A, but it is not state 0. Okay, it is state 3. Now state 3. It is not state 0, Sagar. Okay, understood? Yeah, yes, Markovian is correct. Lomit and SM, correct, ma. Did you understand? Why it is Markovian? Because it depends only on the previous state, preceding state, not on all the other previous states. It depends only on the preceding state, not all the previous state. Not all the previous state. Yes, therefore, it is Markovian. Understood? This is how you have to explain. You have to start from, suppose if you start from A, then you can go to B, and from B, B can throw it to C, and so on. Understood? Yes. Now what you have to, what is asked? Find the transition matrix. This is the transition matrix. This is the transition matrix. Transition means what? All the probability of the transition state. Transient means what? Changing. Okay. Therefore, now what else is there? Yes, it is Markovian we have written, and the transition, this is called transition probability matrix. TPM means transition probability matrix. All the states ergodic. Whenever you are asked to find out whether it is ergodic or recurrent and all, you please draw the graph. Draw the graph. Okay. Then only it will be easy for you. Right? With the matrix it will be difficult. So definitely if you can do that, no problem. But it will be very easy if you draw the graph. Okay. So what are the values? 0, A is throwing to B, B is always throwing to C, C can throw to A and B. Okay. It is ergodic. Ergodic. Okay. Sai Nagesh, just now I have explained, 2-3 times I have explained. Okay. Ergodic, just rewind that. Okay. You just replay it and you can go through. If you still have any doubt, please post your doubts. I'll clear that. Okay. Yes, ma. Now people will kill me if I start again. Okay. Don't worry, you please go through, because 2-3 times I have explained the same thing. Ergodic and all. Yeah, it is ergodic. Yes, ma. Very good. Very good. Very good, Sharanya. Understood, right? Okay. What about recurrency? It is ergodic is correct. What about recurrent states? What about ABC? Is A, before that you have to. No problem, Nagesh. You can go through. It is available in the YouTube, no more. So please go through that. Okay. Yeah. From A, B. Anyway, I'll explain for the problem. You try to understand. Okay. C. From A, you have to go to B with probability 1. And from B, you can go to C with probability 1. And from C, you can go back to B with probability 1/2. Or from C, you can go to A with probability 1/2. Okay. Hey, it is recurrent. SM. It is recurrent. From A, see, you should be able to come back to the same state, right? From A, if I start, I can go here, here, and here. Even if you go here again, you have to come back here only, no? So definitely it is recurrent. It is recurrent. A is recurrent. What about B? From B also, I can go to C and come back, or go to C and A, then come back. Definitely it is. It is. It is. All the three are recurrent, ma. All the three are recurrent. It is aperiodic. Yes, ma. All the states are SM. Did you understand? From A, you can go to B, B to C, then again 1. Or you can go to B and C, then again come back to B, again go to C and 1. Okay, definitely. No, ma, not matrix. Don't write with matrix. The matrix, the same representation is here. This is the graphical representation. Graphical representation of TPM. This matrix only. The graphical representation of this matrix only. This is the graphical representation of this matrix only. Understood? Yes. Okay. Okay. Yes, ma. What about the period? Period. What about period A? D of A, D of B, D of C. From A, 1, 2, 3. One path. 1, 2, 3, 4 and 5. Another path, right? So whenever you get more than 1, you have to go for taking GCD, right? So GCD is 1. Got it? Yes, all are recurrent. Yes, ma, correct, Sharanya. All are recurrent. What about period? What about period? Whenever you have, if you are not able to come back, then the period is 1. If you have only one route, one path, then the number of path is the period. Whenever you get more than one path, take the GCD. D of A is 3. Hey, come on. 5 also is there. No, just now I have explained. Yes, Sagar. Yes, got it. Yes, ma, sorry. Yes, got. All periods are 1, Lomit. Correct. All periods are 1. Yes, D of B is also 1. D of C is also 1. Yes, very good. Therefore, what? So what? Therefore, D of A is 1. Correct. Yes, Sam. Very good. Very good. All the 3 are aperiodic. Yes, very good. Sharanya, correct. Very good. Very good. Excellent, all of you. Very good. Therefore what? Therefore, it is. What about the states? Ergodic. Is it ergodic or not? It is ergodic. It is ergodic. Okay. All the states are ergodic. If all the states are ergodic, the Markovian process is also ergodic. Yes, ma. All the states are ergodic. All the states are, you can say, aperiodic and hence ergodic. And hence ergodic. Very good. Very good. Got it now? Yes, ma. Very good. Yes. Super, all of you. Yes. Sagar, Lomit. Yes, Yerma. Yes, ma. Correct. Ergodic is right. Now, next is irreducible. When will you say that it is irreducible? One definite question you can expect like this also. First of all, you should check whether it is a transition probability matrix or not. When will you say that it is a transition probability matrix? The row sum should be 1, right? So 0.3 plus 0.7, 1. Here also, if you add the sum of the rows, it should be 1. Yes, all the rows are having sum 1, right? Therefore, what? Now, irreducible. Even for here, you please draw the graph. Okay, so this, let us say it is 1, 2, 3. 1, 2, 3 or ABC you can say. Okay. So 1, from 1 you can go to 2 with probability 3, right? Sorry. From 1 to 1 there is a probability with 0.3 and here 1 to 2 you can go to, from 1 to 2 you can go with 0.7. 1 to 3 there is no way. Okay. From 2 to 1 you can go back. This is 0.7. From 2 to 1, you can go back with probability 0.1, right? From 2 to 1, yes. What about from 2 to 2? Yes, there is a loop. It is 0.4. From 2 to 3, what about 2 to 3? It is 0.5, right? From 2, 0.1, 0.4, yes, 0.5. When you add all these things, you should get 3, okay? What about from 3 to 1? No possibility. From 3 to 2, yes, you can go to 3 to 2 with probability 0.2 and 3 to 3 it is 0.8. 0.8. Okay. Regular conditions only. Yes, ma. Diagonal. No, it is not regular. It is not asked for regular, ma. Diagonal element need not be 1. It is sum. See, 0.3, Sai Nagesh, 0.3 plus row sum should be 1 more. Row sum should be 1. If you add all the rows, each row should be 1. Okay. Then only it is called transition probability matrix. Actually, from 1 you can be either at the state 1 or you can go to 2. When you add the probability of staying at 1 is 0.3. Yesterday's class, if you listen, you will understand. The probability of remaining in the same state or probability of going to the next state. Yesterday I have given with okay, Sagar. Yes, ma'am. Okay, no problem. That is for regular condition. Yes, Sagar. Yes, ma'am. If you want to check whether it is regular or not, then you have to check that. Yes. You please listen yesterday's class, Nagesh. Then it will be easy for you. Okay. We have discussed that. Now tell me, what about accessible to each other or not? From 1. See, from 1 to 2. Yes, I can go to 2. From 1, can I go to 3? Yes. Yes, ma. So, 2, from 2, 1 is accessible. 1 is accessible from 2, 3. Similarly, from 2, you are able to go to 1. Yes. From 2 you are go to 3. Yes. Yes. What about from 3? I can go to 2. I can go to 1 also. If you consider any state, you should be able to reach all the other states. Yeah. Each period is 1. No, not regular. Need not be regular. No relationship between regular and irreducible and all. Yes, ma. Yes, yes. Yes, not required. Okay. Yeah. Now the question is it irreducible or not? Is it irreducible or not? If you are able to reach from each state to all the other remaining states, then it is irreducible. So now all are accessible. All the states are accessible from each other. All the states are accessible from each other. Accessible from each other. Therefore, it is irreducible. So, please write these things and remember. Otherwise, you will get confused. Okay, irreducible, because so many definitions are there. No, irreducible means you should be able to reach from every state to all the other states. Yeah. Okay, got it? Understood? Please practice once again, otherwise you will get confused with irreducible, ergodic, period, all those things. Please practice once. With the same Josh, you have to practice, otherwise you will forget. Okay? If you have any doubts, you can ask, otherwise we will close. Yes, ma, any other doubts? Next class will be, if I'm comfortable, I'll take on Wednesday. Otherwise, Thursday and Friday I'll take. Okay. Mostly I'll take on Wednesday. All questions are important, ma. Yes, ma. Definitely, I'll take some questions. Okay. These questions, no, in that let's study Cosm. We have, I have, actually the proof is not there, ma'am, here. Poisson process is Markov process. If you want, I'll give a separate video for that. Okay. In our syllabus, it is not there. Nagesh, I don't believe in giving notes, ma. You have to take your own notes. Okay. Yes. Yes. You have to take your own notes. Please, with the listen to the classes and thank you, Sagar. Thank you, Sagar. Unit 5 is almost over. Almost over. If you want more problems, I'll take. Otherwise, we'll go to that Wednesday's class. In the next class, I'll go to Unit 3 remaining topics. T, F and chi-squared and all. Okay. Yes, ma'am. Okay. Okay, ma'am. Yes, ma'am. Any other doubts? This is actually Sudha, ma'am. This is for JNUH. I think it is not there. The syllabus, in the syllabus, it is not there. Okay, that's why I didn't take. Yes, ma'am. Any other doubts, ma'am? So in the next class, this is over. Almost 5th unit is over. And more problems. Okay, we will see, because only 1 week is there. No, SM. Only 1 week is there. I want to complete that also. Right? Yes. Okay, ma. Thank you. Thank you, Nagesh. Thank you, ma. Please go through that. Let's study COSM. I have completed important questions. Mostly important topics I have taken. Okay. Yeah. Okay. Okay. Okay, ma. Revision is over almost. Unit 3 part 2 will go. That is the T distribution. T test is there. S squared and chi-squared. Okay. Yes. Okay, ma. Thank you so much for listening. Okay. So mostly I'll take on Wednesday. If it is not possible, then I'll compensate on Thursday. Anyway, I'll upload. No, you have subscribed, right? Then you will get the notification. I don't leave any unit. I don't suggest to leave any, skip any unit as a whole, MySM. Please don't leave any unit as a whole. 3 units means fifth unit you can study because it is the smallest unit. Very small unit. Fourth unit I'll suggest. Fourth, third, 3, 4, 5 is very easy. And even the first and second, that definite questions will be there. Like, for example, if the first unit, no, basics of probability questions you can expect, and this one, discrete and continuous probabilities, find the mean, variance, those kind of questions, standard questions will be there. You can expect those kind of questions. So repeated questions you can concentrate, but don't leave any unit as a whole. Okay. Okay, yeah. You can keep it in 1.5 speed, ma. You need not listen to all the classes continuously with one speed. You can increase the speed. Okay. 1.5 speed you can keep it and you can listen. Easily you can cover. Yeah. Base theorem I have taken. In first unit itself I have taken. Base theorem is there. Very important. One definite question you can expect from base theorem. Okay. Yes. Okay, ma, good night. See you in the next class.